I'm Emily Jiang. Thanks for coming to this session on building a 12-factor microservices. So this has two parts. The first part I go through the concept of 12-factor, and the second part will be a live coding session. So at the end of this session, you should be able to build a 12-factor app yourself using MicroProfile. So a little bit about myself. I'm a Java champion. I'm STSM at IBM. I'm a Liberty architect for MicroProfile and CDI. I spend a lot of time working on the MicroProfile specifications such as config, fault tolerance, service mesh, and also the starter and etc. I'm also in the CDI expert group. I work in IBM in the UK, based in Hursley Lab. It's a really nice lab. It's in the countryside area. So one day, if you come around to the UK, and highly recommend you pay a visit at Hursley Lab. So this is the structure of this talk. It's a concept and then followed by the real practice. Okay, so the 12-factor. So how many of you have heard of this 12-factor? Great. So it's how many of you use the 12-factor in practice for building your microservices? Okay. So you came to the right place. So hopefully by the end of this session, you know how to apply 12-factor app to your microservices. So it's 12-factor is the kind of methodology is kind of created by Heroku. So it's the best practice and manifesto. However, for 12-factor, is basically to tell you the best practices. Is one big thing with 12-factor is define a clear boundary between the application and the infrastructure. So this is really, really important. You do not want your application to do everything. You need your infrastructure to take care of the base they are good at. And your application should focus on business logic. So here you go. This is the description of 12-factor. So this is the declarative format for setting up automation and clear contract between the application and the infrastructure. And once you have you apply the 12-factor, you stay assured your application, your microservice is a cloud-native microservice. And also is the kind of you also should think about a CI/CD pipeline, and also your microservice is capable of being scaled up or scaled down, and etc. So this is the 12-factor. So it's a code-based dependency and etc. I go through in the next few slides for each of the factor to tell you what it really what it means. So it's in this 12-factor in practice, I use MicroProfile to implement the 12-factor. A little bit about MicroProfile. How many of you have heard of MicroProfile? Oh, brilliant. So how many of you using MicroProfile for production? Okay, good. A few hands. Recently, like Eclipse Foundation have done a survey about MicroProfile. So MicroProfile has been around for over 2 years. It's a huge open source community. Is in 2018 there's a 13% like live microservices. 13% companies use MicroProfile for their production, and in April this year, it's 28%. People already switched to MicroProfile. MicroProfile is a completely open source community. Is established in 2016 by IBM, Red Hat, Piara, London Java community, and etc. And later on, Microsoft and Oracle all joined. Is completely community driven. Is no reference implementation. So it's all the implementations are equal. So we do not want to differentiate the implementation, which is different from the JSR and etc. Different from the Java EE. And we open sourced all the API, TCK, and specification. You can freely download the API and also the TCK from the Maven Central. Is Apache V2 license. So MicroProfile has quite a few application server to do the implementation. In IBM, we have Open Liberty, which is a completely open source, and you can see the source code, etc. is free for production. You can buy the support if you want, and also has WebSphere Liberty. In Red Hat, it has Thorntail, Quarkus, and SmallRye, and also Payara has Payara, and also the Tommy Tribe has Tommy EE, and Cumulus EE, and etc. Oracle has Halidon. So you can see there's a lot for you to choose from once you choose MicroProfile. On the left, so in MicroProfile, we have 8 specifications for you to use to build your microservices. So REST service, Open API, security, fault tolerance config, and etc. So this is a quick timeline for the release. As you can see how fast it's been progressed since 2016, and now is we have MicroProfile 2.2. Later on, I demo to use MicroProfile 2.2 to create microservices. And the other thing is that I work for IBM is purely on the most of the time on Open Liberty. Open Liberty is one of the implementation of MicroProfile, and also Java EE that has a monthly release, and we put a MicroProfile on the top of our priority list. So strongly support cloud native application development. Okay, let's go to the now you have a kind of rough idea about what MicroProfile. Now let's go back to the 12 factors. The first one, the code base. Basically, in code base is every microservice should have a dedicated code base. You shouldn't share, code base among multiple projects, multiple microservices. How many of you use this best practices already? Okay, that's cool. It's I think in the earlier keynote also the speaker also mentioned, because if you work on a dedicated code base, there's less interaction between the different teams. You don't trip on each other's toes, and etc. The second one is dependency, and when you do the microservices, you should you either use Maven or Gradle, and you specify your dependencies in your POM XML if you use Maven. So do not pre-package libraries inside your application. You should always update to the latest version of the libraries. Do not directly wire that library in your application, and then you never be able to move up for security fixes and etc. The third one is very important. Externalize your configuration. Basically, once you do microservices, you want to adopt the best practices. The written ones run everywhere. So you want to externalize your configuration. When the microservice deployed to the cloud, you're free to configure it in the infrastructure. You do not need to repackage your application because of changing one configuration, etc. So if you use Kubernetes, is very popular cloud infrastructure. Who else is using Kubernetes? Okay, good. For the ones you have not used Kubernetes, you should start to look into Kubernetes. If you use Kubernetes, the config map and secrets is the ideal place to store configuration. And then we can use MicroProfile config directly inject the configuration in your application, so you can free change the values and etc. So the fourth one is the backend service. For backend service, basically this is a kind of fashion, all the backend or back services, they should be loosely coupled. Basically, you can free to switch the backend services, and they are configurable. For example, one day you use Twitter as the median, social media, and then the other day maybe you use a different some other social media application. This is kind of, if you make it configurable, you are free to switch among the different backend. So the fifth one is build, release, and run. So you need to have the kind of very clear-cut phase. You have a build phase and release and run. So whenever you change the source code, you need to build and then go through release and then go through run. So that's we want to minimize this build, release, run iteration. Unless this is necessary, you do not kind of completely go to build, release, run all the time. So that's why we want to externalize your configuration. For the configuration changes, you shouldn't need to go to release, build, run, because if you externalize your configuration, you don't need to do the build, release, run, because the application will be stay the same. So there's some other tools like CI/CD pipeline, like IBM or Urban Code deploy AWS, Azure, whole got a similar CI/CD pipeline for you to choose from. This is processes. So this is very important for the processes. When you build your microservices, they should be stateless. The reason it's being stateless, that's because in the cloud infrastructure, it's free to kind of scale up your microservice or scale down when it has less usage and etc. If it has a state, and when you scale up, when you scale down, and you will lose all the state and etc. So this is we always remember to create like a stateless and share nothing this microservice. And one of the best practices is one of the kind of most adopted way to do these stateless processes is to use RESTful API. So the next one is the port binding. So this port binding is when you deploy your microservices to the cloud, you are not a standalone, and some other microservice will discover it and utilize it. And maybe you will discover some other microservice utilize it. However, when you code up your application, you have no way to know what's the backend microservice port. So you always need to make sure this port can be rebounded by the in the infrastructure. So the eighth one is concurrency. So again, this one is previously we talked about processes. So processes is the stateless processes, and concurrency is like when this microservice is under heavy load, you can scale up. So a cloud infrastructure is free to scale up, have put in more instances of it. So this is called a concurrency. When it is less busy and then can scale down. So Kubernetes is great to be able to cope with this, be able to provide support for the concurrency. Like a Kubernetes auto scale, you can define what's the minimum instance, what's the maximum instance, and etc. The next one is disposability. So this one is when you create your microservice, you always need to think, okay, your microservice is kind of has no taste. Basically, you should treat it as a cattle instead of pet. You know, if you have pet, if this pet is ill and etc., you need to take to the vet, and also you have personal attachment to this pet. But if it's cattle, if it's ill, and then there's less attachment to this cattle, basically is you can directly replace by another one. So this is disposability. Disposability. The other thing for the microservice is the need to be shut down very quickly and start up very fast. The reason for being this is if you deploy microservice to the cloud, every minute when it's running in the cloud, you have to pay for it. So if it's kind of starting up too slowly, and then that clock started ticking, and you have to spend the money on it, even though you haven't done anything at all. And the other thing is your microservices should be fault tolerant, resilient. Under whatever the situation is, your microservice should always perform well. So this is a feature you need to consider of it. So you can use MicroProfile fault tolerance to make sure your micro service is bulletproof. Basically, it's very resilient itself. So the next one is the dev product parity. So basically, we are saying when you do the development, you should use the same team to operate it as well. So now we do everything. We do the development, we test, and then we put it in the production. So and also we keep the environment the same as well. So how many of you use Docker? Okay, great. Docker is a great way, trying to keep dev and production in the same. So it's if you have not learned Docker, you should start to do some reading to learn about Docker. So so Docker is a great way to keep the dev prod parity. So once you use Docker, so you can rest assured is when you develop this microservice, it should run as well as in the development phase. And when you deploy microservice to the cloud, and also trying to use a Helm chart to create your deployment YAML file and all the templates to deploy to the cloud as well. The next one is the logs. So it's the logs, because in microservices, when it's in the cloud and then it's running in the pod, and sometimes there's more instance of it, and sometimes some instance will be killed, and etc. So you need to think you don't want to lose the log. So it's one of the best practices is you either persist the log somewhere, or you directly streaming out the log and then directly send to ELK. So directly they can do the correlation, etc. You can persist the log. So log is a great topic to discuss in the microservice world. So how many of you use Java U2 log? Okay, nobody. How many of you use SLF4J? Cool. How many of you use Log4j? Okay, looks like SLF4J API is kind of more popular. That's interesting, because we are trying to in MicroProfile we are also trying to see what's the consensus. I mean, what's the trend currently? What's the microservice developer? Which logger API microservice developer is using? We are trying to see whether the application server should support the similar APIs. So that when you write your microservice running on Songtail, and later on you want to port to OpenLiberty, and you can still get your log streamed out to also get to the log stash and etc. to view the log, and your log information won't get lost and etc. Anyway, one is the way to do the logging is write all the logs to the standard out. The final one is the admin processes. There's some admin processes such as database migration and etc. Do not put the one-off processes in your microservices. So it's basically you can directly create as an admin job directly running in Kubernetes kube control EXEC. Do not create this one-off database migration inside your microservice, do the if statement and etc. This is not good for the code maintenance and etc. So that's a big, quick go through about the 12 factor. So to recap it, so the first one is code base. Each microservice should have its own dedicated project dedicated GitHub repository. So you use GitHub to solve the problem. Dependency, Maven or Gradle. And config, you can use MicroProfile. And backing service, you can use MicroProfile config to directly configure backend service as well. Build, release, run is more like a your process. So basically, best practices the way you operate your project. And the processes, you use the REST API, so from it, the MicroProfile. And port binding, you can use MicroProfile config directly bind the port. Concurrency, you can use Kubernetes auto scale or scale up or down. And disposability, you can use MicroProfile fault tolerance to make sure your microservice is bulletproof, so it's resilient. And dev prod parity, so you can adopt a Docker, so and make sure is your dev prod stays as the same as possible. And the logs, you need to stream out the logs. Make sure when you develop your microservices, make sure you need to remember, okay, this log need to be streamed out or persist somewhere. You need to remember the microservice. If it's stored in itself, it might get destroyed, this instance, at any given time. Your information will get lost. And admin processes is one of processes you should create a job and directly executed by Kubernetes. So this is quickly, recap of the whole 12 factor. Is not rocket science. Like in the next couple of slides, I'll quickly go through the config and fault tolerance so you can see how it works. So for config is you can define the config name and value somewhere in the externalized location. And then you can use MicroProfile config API directly inject into your microservice. So in these slides, you can, there's a two-way to inject this config into your microservice. The first one, you can do a programmatic lookup. Config provider.get config, and then you config.get value. The first parameter is the config name, and then the second one is the config type. So you can easily inject it using CDI. You can do an @inject config property, and then followed by the config name. So this is another way to do the static config and dynamic config. As you know, CDI. Any of you use CDI? Okay, good. How many of you heard of CDI? Okay, good. If you know Spring, CDI is equivalent to Spring injection. Is if you see @inject is equivalent to Spring @autowired. So it's the same. It's a CDI bin. You cannot Spring bin. In MicroProfile config, all the config sources are layered. So they have priority. It's called ordinal. So inside your application, you can have a config source called microprofile-config.properties on the class path. It has a lower priority. And then the environment variable has a higher priority, which is 300, can overwrite the config declared inside the application. So you can do the dynamic config. So if the config name value change, you can directly get the up-to-date value. Just use a wrapper, inject a provider. The other one is the fault tolerance. Fault tolerance is the way to create a resilient microservices. It has these 5 annotations: retry, circuit breaker, bulkhead, and timeout, and fallback. So this is pretty much self-explanatory. How many of you use historics or no historics? Okay, if you know historics, you should have the rough idea. This is quite similar to historics. Okay, with that, so let's start the second part, which is I'm doing a kind of practical coding session to show you how to create microservices by using MicroProfile to fulfill the 12 factor. So to get started is the first one, we go to the MicroProfile starter website. For the other link is openliberty.io guide. If you want to know anything about microprofile, any spec, and then click on that. So there's a documentation. So and for you to try. Okay, let's go to the website. Where's the this one is cannot. Why is it coming here? Strange. Why is the mouse that doesn't cannot move? Okay, better. Okay. Oh, you cannot see the screen anymore. Oh. Okay, good. Please. Yeah, it works. So this is the starter.microprofile.io. So now I want to create my microservice. I can see service B, SB. And then I can choose the latest microprofile, which is 2.2. And I can see the two application server implement. I choose Open Liberty. So basically, what I really want to do is I just want to create a RESTful microservice. So here, so I have SB, new window. See okay? Okay, go to download, go to SB. I can directly do a Maven clean package. And in the meanwhile, I can import that SB into my IDE here. Import. See the, let me make it bigger. See here. So what is generated is two things. One is one is the JAX resources. The other one is the application. If you know the Spring Boot, this is more like the Spring Boot, the root. So this is called a JAX application path. And then this is a JAX resources. So this is a directory REST. So now I think that server started. So we can go here. So the POM XML is generated. So if you go to the bottom, so it's 8181. So if I do a Java -jar target SB Java jar. So now we know it's 8181. So SB. See, it will say hello world. So if we say, okay, let's make a change here. Let's say hello GeeCON. And also, I want put a fault here. So I do something like that. So every 3 requests, I want, if it's divided by 3, I want a 3 exception. So just do like that. Save that. So in here, I stop it. So it's directly stopped. And then I do a Maven package and rebuild it. Java -jar target sb.jar. And while it's doing that, that's a microservice being created. Nothing fancy, it's just a REST microservice. So while it's doing is a building and etc., I want to create another microservice. So this time I create SA. So again, use the Open Liberty. I leave the health check here. Here, and then into SA. So in the meanwhile, let me import SA in here. Browse. Again, nothing is rocket science. So SA created similar to what a SB looks like. However, before we do anything, let's see whether SB is come up or not. So here is SB, right? So do that like that. Sometimes you can see hello GeeCON, right? That's what I put in. And sometimes it's not working. This is on purpose, so I simulate our real-time, scenario. Sometimes we have bug in the code. Okay, now we have a service B, which is RESTful microservice. Now I also create a service A, but in service A, I really want to call service B. So I discovered service B, and I want directly call service B. How do I do it? So in service B, I can easily use the Open API. I can find out what a service B API like. So it has it's directly bind to here, this location, and it's pass data and hello. And his operation is a get operation, is say hello. So in service A, I can directly create that client. So in order to save me time, so I can directly I can directly copy it. I copy this one. So I show you after I have copied. So I show you here, service B, service A, I directly register REST client with base URI. Here is we know is here is SB data hello, which is the location. However, this is all configurable. Once you go to the Kubernetes, you can rebind it to whatever, and then you can do we know it's the get operation. And also here we said say hello. So let's go back to C. So here is say hello, and also here is get. Let me delete this. So this is kind of this is a service API I want to call in service A. So how do I call it? This is just an API. So in the resources, we can directly inject. We can just say inject REST client and then service B client, service B. So here, instead of say hello world, I can say service A. I can say service B dot say hello. Let's see. Okay, let's go to another terminal. Let's go to download. Go to SA. Just manually install and directly run it. Java -jar target. I know it's going to be called SA. Oh, okay. Before I do that, okay. There's another thing is because the generator directly bind me to the same port. So however, if I want to get it tested, so I have to change the port to be bind a different port. So I can easily change it here, 9080. Here I can do 84. I do it again. So this is SA. So it's directly build it. So it's use Open Liberty, the 1904 is expanding. And then can package a server. And then it will start. Okay, now this is the service B, right? We know the service B sometimes not working. Now let's go to service A. So the is 9080 SA. See, service A, hello GeeCON, right? And sometimes it's not working. Do you know why it's not working? Because the service B did not work, right? Now I demonstrate how can you fix yourself. For example, you call the backend. Backend is not maintained by yourself. And sometimes you don't know where to get the service from, like a real lifetime support from. And you have to do it yourself. So here, so I demonstrated you. So how can I make my service fault tolerance? So all I need to do here, I just say, okay, please retry it. The retry is the MicroProfile fault tolerance. Now I retry it. Now here, I can directly build it. And then it will come hopefully it will come back all the time. So it's up to now. So we build one microservice, right? One microservice which is service B REST, and then we use and then we build another microservice called the previous microservice we built is service B, and then is let's see. See, it worked all the time, right? Yeah? Is that easy? So you don't need to do anything else. You just add this annotation. So basically, the major mission of MicroProfile is for you to concentrate on your business logic. The MicroProfile will just do all the quality service for you. So this is one thing. The other thing is you can easily inject the configuration to your microservice here. So in here, in the generated code, we have resources. We have this MicroProfile config. For example, I just say username, and I say Emily. Can save that, and then in here I can directly inject that. I can say here inject config property name equals username string username. So service A, I can just say, instead of say service A, I say hello. I can say username so, and then I can directly rebuild it. Yeah, so where is the rebuild it and starting up? So you can use the config to directly inject this. And then for this, you will say, okay, this is defined inside the application. However, you can overwrite it by setting either in Kubernetes setting an environment or in the or using config map to directly set it. So it's one thing is I want to show you is all my like this sample is on my personal GitHub. So I have 12-factor service A and a 12-factor service B, and also I have a 12-factor deployment. So basically, I have a Minikube deployed, so you can directly to follow the instruction there. Let me see. See, you can say hello, Emily, right? So, but I show you the real bit. So basically we don't have time to like package it and then deploy to Kubernetes. After you have to build all this, the next step is to Dockerize it. So you can write a Docker file to Dockerize it to create the container, and then you can deploy to Kubernetes to the cloud and etc. I have instruction here. If you say Emily, GitHub. So you can see 12-factor app A, app B, and deployment. In the 12-factor deployment, I have the instruction for you to install Minikube and do the directly to see the Docker side as well and the Kubernetes side. So however, I set up all for you here. Okay. So I just want to demonstrate the things that you can easily scale up. So you can see the kube control and get ports. You can see all the ports, right? And then you can easily to scale. So you can say, okay, I scale this to be 5. And now if you do a get deploy, so you can see the 5 instances. You can scale up and down. And the next thing is in here. As I say, I define a username in my app. So it's after I deploy my app, you can easily overwrite it in the Kubernetes YAML file. So you can define as the environment variable. You can say GeeCON, and then in the application here, and you can do Minikube IP. You can get a hold of IP, and also is you do a you can kube control get services, and then you have an IP, and then also the port is 300. So you can easily say Untitled MOA. See, dear GeeCON, so this GeeCON is directly in the YAML file is you configured. So with that, that's the end of my talk. So I have resources for you to take away. No, here. So it's all in my. Later on, I will share the link to my slides. I don't think I have time for questions. What is the major advantage? I use one second. MicroProfile over Spring Boot. This is an excellent question. So it's there's three major advantage. The first one is the de facto standard of MicroProfile, because as you see, probably all of the application server and big vendors support MicroProfile. So this is the one thing. The second one is this allow you to build a very thin wall. So the application server has all the implementation for you. Your wall is very tiny, which is great for cloud native deployment. The third thing is very simple, is less code, is you don't need to call a lot of APIs, as I have demonstrated for you. So hope this is, you have get a taste of it. I think, and then I will go outside to answer the second question, what types the current supported configure property and etc. Yeah, I will go outside if you have questions, and we will continue the discussion. Thank you so much for coming.